Good morning, students. So today we are going to see about the laws of chemical combination, isn't it? Already I started this lesson. This topic, laws of chemical combination. What are the five laws of chemical combination? One is law of conservation of mass. Second one, law of what? Constant proportion, definite proportion, multiple proportion, reciprocal proportion, and Gay-Lussac's volume. Isn't it? Totally 5 laws are there. First two you might study in 8th standard. Third, already I taught for you last class. What is that? Law of multiple proportion. So law of multiple proportion states that what? When two elements, that is A and B, combine each other and they can produce more than two compounds. What are they? AB and AB1, isn't it? According to law of multiple proportion, two elements that combine each other, for example A and B, when they combine each other they can produce more than one compound, that AB and AB1. In this, the proportion of A is constant, isn't it? The mass of A is constant, which combines different weight with the B and B1, isn't it? Today we can see briefly about law of reciprocal proportion. That is the fourth law in laws of chemical combination. That is law of reciprocal proportion. So in law of multiple proportion, I state that only two elements are there, A and B. Here we are going to take three elements, that is A, B and C, isn't it? So in law of reciprocal proportion, we can take three elements, that is A, B and C. Okay. The element A is going to combine with B and C separately. The element A is going to combine with B and C separately to form ABAC. Okay, here the three elements, that is A, B and C. A is going to combine with two different elements separately to form two different compounds, that is AB and AC. In turn, this B and C combines together to form BC. Okay, so three elements are there, A, B and C. A is going to combine separately with B and C to form two different compounds, that is AB and AC. In turn, the compound B and C combine together to form BC. Okay. In this, the proportion in which they combine with A and in turn they are combining with BC is same. Okay. That is the B and C, what proportion we will get? The same proportion we will get when we divide AB and AC. Okay. So law of multiple proportion states that when three different elements combines with each other, the A combines separately with B and C to form two different compounds, that is AB and AC. In turn, the compound B and C combines together to form the third compound, that is BC. The proportion in which we will get AB and AC is similar to that of BC. So we can see this through an example. For example, take the element A as carbon, B hydrogen and C as oxygen. So we have taken three different elements. One is A, carbon, B, hydrogen, C, oxygen. Okay. Carbon combines with hydrogen to form methane. Carbon combines with hydrogen to form the first compound, that is AB compound, methane. Okay. The next one, A combines with C to form what? Carbon monoxide. Okay. That is the next compound, AC. So carbon combines with hydrogen to form methane. CH4 means methane. This is the first compound. In turn, A combines with C, oxygen, to form carbon monoxide. Okay, that is a AC. In turn, this compound, that is B and C, it combines to give water. Hydrogen combines with oxygen to form water. Okay, so three different compounds we get. That is, one is methane, AB, AC is what? Carbon monoxide, and BC is H2O molecules. Okay. So here the value of carbon in both is constant. The value of carbon is constant. What is the mass of carbon? 12 gram. The mass of the carbon is what? 12 gram. Okay. Here methane, either it can form one molecule of oxygen, means it form carbon monoxide. Two molecules means it can form what? Carbon dioxide. In both the cases, here carbon 12 gram, here also carbon 12 gram. Here the mass of the hydrogen is 1. So 4 into 1, 4. Here the mass of the oxygen is 16. 16 into 2, 32. So we can take the proportion now, isn't it? 4 divided by 12. The proportion of hydrogen and oxygen that combines with the carbon. Here the value of carbon is fixed to 1. So we are going to take the proportion of hydrogen and oxygen. 4 divided by 32. So what's value you will get? 1 is to 8. 1 is to 8. Okay, students, we are learning about what? Law of chemical combination. First itself, under itself I said, what is law of chemical combination means? In chemistry, the elements combines with each other to produce different types of compounds, isn't it? And this combination is governed by certain laws. According to that laws, only each elements combine. It only given under the heading laws of chemical combination. Okay, all the chemical reactions will be based on this law. Any one law behind this reaction it governs. Okay, in that 5 laws are there. One is what? Law of conservation of mass, law of constant proportion, law of definite proportion, law of multiple proportion and reciprocal proportion. Already I taught for you multiple proportion. Multiple proportion means what? 2 elements combines each other to produce more than one compound. Among that, one of the compound have what? A constant proportion. Here we are going to learn law of reciprocal proportion. Here we are going to take 3 elements. 3 different elements combines each other. Okay. For example, A, B, C. A is carbon, B hydrogen, C oxygen. Okay. Here A, B and C combine separately with A to form 2 different compounds. Okay, what is the different compounds? One is methane, next one is carbon. 1 molecule of oxygen means carbon monoxide, 2 means carbon dioxide. Okay, so it can produce 2 different compounds. One is methane and carbon dioxide. In this, the mass of carbon is fixed to 1. And oxygen and carbon is combining with the carbon in different forms, okay, to produce methane and carbon dioxide. And if we take the proportion of hydrogen and oxygen that is combining with the carbon is 1 is to 8. In turn, this compound, that is what? B and C, in turn combines together to form H2O. So here, hydrogen, what is the mass of hydrogen? 2 into 1, 2. Okay, mass is 16. So what is the ratio we will get? 2 divided by 16, we will get 1 is to 8. So you can consider this as equation 1 and here equation 2. Okay, so they are in turn, they have same proportions. Okay, ma? Have you understood? So when 3 elements are combining, the third element, the third compound has same proportion as that of the first 2 compounds. See here, hydrogen and oxygen, in which ratio they are combining with the carbon, the same ratio they are combining with each other. So from the equation 1 and 2, it relates what? Law of reciprocal proportion. Either it combine in simple ratio or it will be in the multiple forms. Here 1 is to take the multiple forms, it will combine here. That is called as what? Law of reciprocal proportions. Okay. So in which proportion hydrogen and oxygen is combining with the carbon, the same proportion that element B and C in turn combine with each other and they produce same ratio, or in some cases they will produce the multiple ratio of the first one. 1 is to 8 means the double of that compound will be found here. This is only called as what? Law of reciprocal proportions. Okay. The next one is law of combining gaseous volumes, that is Gay-Lussac law. The next one is Gay-Lussac's law. This Gay-Lussac's law only applicable for gaseous volumes. Okay. It is only applicable for gaseous volumes. See, according to this law, whenever gases react, they produce a simple whole number ratio. When the reacting molecule is gas, okay, it is not a solid or liquid, it is not applicable, only it is applicable for gaseous compounds or water vapor, okay. Gaseous means either gas or water vapor. If that reacting molecule is gas, then they will produce simple whole number ratios. When 2 compounds, that is A and B, if both are gases, they react to produce a gaseous molecules. For example, hydrogen combines with oxygen to form water vapor H2O. They will produce a simple whole number ratio. For example, 2 volumes of hydrogen combines with 1 volume of oxygen to produce 2 volumes of water vapor. So Gay-Lussac's law for combining gas, so it is applicable only for gas or water vapors. Okay, according to this law, when our reacting substance is gas, always they combine and symbol ratio, always they combine in symbol. See here, what is the ratio? Here 2, here 1 volume of oxygen gives 2 volumes of, this is a simple whole number ratio. They will not in decimal or not in fraction, they will give, always they will combine in whole number ratio. Okay, so whenever gases react, here hydrogen, okay, whenever gases react, they react what? In simple whole number ratio. So that is called as Gay-Lussac's law. According to Gay-Lussac's law, whenever gases react, any substance, our reacting molecules will be, or our reactants, if it is a gas, always they combine. Hydrogen reacts with oxygen to form water vapor, isn't it? Nitrogen combines with hydrogen to form ammonia. Always they combine to form simple whole number ratios. Okay, and both the reactant side, this is the reactant side. See, both the reactant side as well as product side, we should measure under STP. We should be measured under STP. Then only they will produce simple whole number ratio. What is STP means? Similar condition of temperature and pressure. Okay. So whenever gases react, for example, one box take fully filled with hydrogen gas. Next, it is filled with oxygen gas to produce water vapor. Okay, water vapor. 2 volumes of hydrogen reacts with 1 volume of oxygen to produce 2 volume of water vapor. All the both reactants and product must be measured. Okay, the volumes or the molecules that present inside this must be measured under STP. What is STP means? Similar conditions of temperature and pressure. Okay, that is when this reaction is taken in, the temperature and pressure should be constant before and after the chemical reactions. Then only they produce what? Simple whole number ratio. Simple whole number ratios. Okay, so both the reacting gases and the product must be measured under same condition of temperature and pressure. For example, 25 degrees Celsius or 1 atmospheric pressure. Okay, at commonly 25 degrees Celsius and 1 atmospheric pressure we should set up, and we have to do this reactions. Okay, then only they will produce what? Simple whole number ratio, and all the 3 boxes must contain a similar number of molecules. That only when we will study later in Avogadro law, equal volume of all gases contain similar molecules. Okay, when we measured in similar temperature and pressure. So this from these 2 laws, that is multiple proportion what? 3 elements are there. The third one also has same proportion as that of the first one. Here law of Gay-Lussac's law, it is applicable for gas. If our reactant is a gases, we should measure all the reactants and products under same temperature and pressure. Then they produce a simple whole number ratio. Not only for this, usually when the gases react with each other, mostly they will react to form a simple 1:1:1, 1:2:1. Always they will react to produce a simple as well as whole number, isn't it? 1, 2, 3 are whole number. 1/2, this is whether it is considered as a whole number? No. 1.1, whether this is considered as a whole number? No. Always they give whole number like 1:2:1 or 1:2:1, 2:1:1. Always they will combine with each other to one volume of oxygen combines with 1 volume of oxygen to produce what? 1 volume of oxygen gas. Okay, similarly always they will be in the simple whole number ratio. This only states by what? Gay-Lussac's. Hence the law is also called as Gay-Lussac's law. And law of multiple proportion was formulated by, who formulated multiple proportion? John Dalton, isn't it? Multiple proportion was formulated by whom? John Dalton. And here reciprocal proportion was Jeremias Richer. Okay, reciprocal proportion was formulated by Jeremias Richer, and this law was formulated by Gay-Lussac. Okay, so according to Gay-Lussac, whenever gases react, okay, the reacting that is the reacting gas as well as the product must be measured under STP. Must be under STP. That is, after the reaction and before the reaction, the temperature and pressure should be constant. And whenever they combine, always they produce a simple whole number ratio. Always they will produce what? Simple whole number ratio. This is the two laws. Okay. One is what? Law of reciprocal proportion. Next one is law of Gay-Lussac's value. Okay. So this is one of book bag question, that is Roman number 3. State Gay-Lussac's law of combining volumes. Okay. State the Gay-Lussac's law of combining volumes explained with an illustration. It is on page number 134. Here it is mentioned. You can see this, isn't it? So this is the here, from here to here, including this diagram. See, one volume of hydrogen combines with one volume of hydrogen. That is totally 2 volumes of hydrogen combines with one volume of oxygen to produce 2 volumes of water vapor. See here, the totally how many hydrogen? The same hydrogen will be present in this volume also. And totally how many hydrogen it will be found here. Here, how many oxygen it will be found here. The total number of hydrogen and total number of oxygen will be equal before the reaction and after the reaction, and all must be measured. All the must be measured under same temperature and pressure. For example, 25 degrees Celsius temperature means 1 atmospheric pressure. Okay. After that, it should be, see, before the reactant 1 temperature and pressure, after that the gas, it is not applicable. For gas, always we should measure both the reactant and the products under what? Same temperature and pressure. That only he is explaining that according to Gay-Lussac's law, whenever gases react, the volume of gas as well as product produce whole number ratios. Here, what is the whole number we will get? 2:1:2. 2:1:2 is the. Similarly, for example, nitrogen combines with hydrogen to form what? Ammonia. They will also produce what? Simple whole number ratio. So this is the important detailed question. Okay. So the next one is quantum number. Next one is quantum number. So last class itself I said what are the shells we have? K shell, L shell, M shell and L shell, isn't it? And according to Niels Bohr, K shell, what are the number of electrons accommodated in given by what formula? 2n square. Formula is given by what? 2n square. According to 2n square formula, K is equal to how much? 2, L is equal to 8, M is equal to 18 and N is equal to 30. So I said already that each orbit has subshells, isn't it? sp, df. Okay. And now we are going to learn about what? Quantum numbers. What is quantum numbers? Means energy levels. Okay. There are 4 quantum numbers. See, for example, if we want to define you, where you are locating, means we will have to give what? Our address, isn't it? Full address, state, district, everything we have to pin code, our house number, everything we should say like that. This quantum number means it defines the properties of electron. It's a theoretical value which gives or which defines the what? Electrons, the properties of electrons. Is it? Its electrons are located in the orbit. How it is located? How it is pinned inside the electron, whether clockwise direction, anti-clockwise direction, in which shells they are located, and what is the maximum amount of energy level each orbit. These are the informations which was given by which number means a quantum numbers, isn't it? First quantum number is principal quantum number, which was denoted by the letter N, that we already studied. What is that? 2n square. Okay. So what is the value? 2, 8, 18 and 32 is the number which says how many electrons that can maximum accommodate in an orbit. This information is given by which value? A principal quantum number. So principal quantum number denoted by the letter N, which define what? Define it. That is how the electrons, how many electrons are located in each orbit, isn't it? K, L, M, N. That information was given by the principal quantum number. That is, we know already 2n square, isn't it? N refers to what? Quantum number. The next one is azimuthal quantum number. That is denoted by the letter L, which says about subshells, which gives the information about subshells. Okay, it says about main shell. It says about what? Main shell. And azimuthal quantum number, it explains about what? Subshells. What are the subshells? Already I explained. What are they? sp, df. Okay. How many electrons? 2, 8, 10, 14. 2, 6, 10, 14. The maximum number of electrons that can be accommodated in S is 2, P 6, D 10 and F is what? 14. And this magnetic quantum number, it says the orientation of electrons, how it is present inside the orbit. Okay. And This one, last one is spin quantum number. So totally 4 quantum numbers are there. What are the principal quantum number? This value explains about the main shell K element. And next one is azimuthal quantum number denoted by the letter L, and it says about the subshells SPDF. S hold 2 is 6, 10, 14. And the next one is magnetic quantum number, which says about the orientation of electron inside the subshells. Orientation of electrons inside the subshells. The last one is spin quantum number, which shows the spinning, the rotation of the spinning of the electrons inside the orbit. Spinning of electrons inside the, either they are moving clockwise direction or anti-clockwise direction. How they revolves around the nucleus in the atom. This information is given by what? Spin quantum number. So 4 quantum number, principal quantum number explains about main shell. Azimuthal quantum number explains about subshell, and magnetic quantum number, the orientation of electrons inside the subshells. Okay. The last one is spin quantum number, how it is spin around the electrons. This information is given by the spin quantum numbers. Okay. In higher classes we will study briefly about this. So this is about the quantum numbers. Quantum numbers means it give the information or give the properties of electrons or the properties of about subatomic part. It's a theoretical value or theoretical number which explains about the defining properties of electrons inside the atom, or it explains about the subshells of the atom. So principal quantum number says about what are the main shells, what are the subshells present in the main shells, and how the electrons are oriented in the subshells, and how they spin around the electrons. So this is about what quantum numbers denoted by the letter N, L, M and S. Okay. Thank you so much.